Today we are 3:20. Talking about logarithms. Logarithms are created to help us answer a question. So in the last unit, we figured out that if I have 2 to the x equals 16, we can solve this equation. We can solve it because we have the one-to-one property. If we make the bases match, 2 to the x would equal 2 to the 4th. And so what does that mean then? X is 4, sure. All right, and so when the bases match, then our exponents must match. That makes perfectly logical sense. Well, that works some of the time. Actually, it works almost never. But what we wanted to be able to do was maybe to figure out, well, 2 to what power equals 22? And I can't rewrite 22 using the same base. Doesn't work. Okay. And so, well, let's see. I can guesstimate. I know that 2 to the 4th is 16. And I know that 2 to the 5th is 32. So x must be between 4 and 5, somewhere inside that range. Okay. What we want to be able to do is actually figure out, well, what is the value of x that gives us 22? And logarithms are going to help us do that. Now, until we get to that point, which comes at the very end of this unit, after spring break, before that, we have to learn all these different properties about logs. Okay, and it starts here with the meaning of logarithms. So just a few, some of my favorites. 3 to the 5th is 243. I don't know why I really like this one, but when I look at it, I see 2, 3, 4, 5. And I just have that, I don't know why. I don't know why, but that's what I see. 2, 3, 4, 5. And it, I don't know. It's totally stupid, right? But okay, sure. Another one of my favorites is 7 cubed. What's 7 cubed? 343. So 343. And again, this is one of those stupid things that my brain is just weird. But when I look at 7, I think, well, 7 is 3 plus 4 to the 3rd power. I don't know. That's weird, but it makes sense in my brain. It doesn't make sense at all. It's just a stupid thing that I remember. Okay. I have all kinds of things like that, like the combination to the safe at our house. All I know is the 3rd number is 3. And for some reason, just that saying helps me remember the rest of the combination. All right, there's a whole pattern involved, but that for me, those things work. Stupid things to remember stuff. That's what I think my job is for you. So speaking of stupid things to remember, the entire unit can be summed up with one phrase today. So we'll talk about the phrase in just a second. But example 1, rewrite the equation in exponential form. Please remember you need to write example 1 and the directions. Rewrite the equation in exponential form. Because what is the point of notes if you don't know what you're supposed to do? So please write the directions. I did collect notes yesterday. If you did not turn in your notes, you need to give them to me today, please, after notes. Rewrite the equation in exponential form. So today is all about the meaning of logarithms. Logarithms come from exponents. Logarithms were created so that we could answer that question. 2 to what power gives us 22? And like most things, I have a stupid phrase. So first of all, this is log base 3 of 9 equals 2. And that's how we read that. So So this is base 3, and we would say of 9 equals 2. It's important that you know how to read these things. So how would you read this? Log base 8 of 1 equals 0. Okay, and how would you read this one? Log base 5 of 1 over 25 equals -2. And here we would have log base b of n equals p. Okay, of is of n, of 1, of 9. That's called the argument. That's usually the thing that's inside the function. We name that the argument. Okay, so this is called a log equation. How do I know that? Because it has log in it. Yes, very good. So this is a log equation because there's a log and there's an equal sign, which makes it an equation. And so what we want to do is we want to write it in exponential form, which means with exponents. And so the phrase of the month here is, how do you drop a log? All right, carefully. All right, how do you drop a log? Which brings all sorts of things to mind. And I have to say that I've been raising kids for the past 11 years. And so basically my entire life for the past 11 years has been potty training. And you keep up, lots of fun little things to make sure you flush and wash things, right? So, okay. So stupid things to remember. How do you drop a log? You give it a swirly. That is the phrase of the month, a swirly. All right. We want to do that here. So how do you drop a log? Give it a swirly. Yeah, see, that's how that works. So I ask a question and you answer. Okay, so how do you drop a log? Give it a swirly. So a swirly, what's a swirly? A swirly is, we start with the base, and just like a toilet swirls, we swirl around and pick up our power. So we have a base of 3 and a power of 2. And we keep swirling around the equal sign until we equal our argument of 9. Is 3 squared equal to 9? True or false? True, yeah, sure. This is exponential form. How do I know it's exponential form? It has an exponent. Done. Okay? That's exponential form. How do you drop a log? Give it a swirly. Okay. So same thing here. We have a base of 8. We're going to give it a swirly. Start with the base, circle around the equal sign, and pick up your power. So 8 to the power of 0. Keep on swirling, and it equals 1. There is exponential form. That's all we're doing, ladies and gentlemen. This is what we're doing today, swirlies. I should see all kinds of little swirlies on your paper, okay? Letter C here, log base 5 of 1 over 25 equals -2. How do you drop a log? Swirly. Yes, so we start with the base, we circle around, and we pick up our power. 5 to the -2 power equals 1 over 125. Does it? Does 5 to the -2 equal 1 over 125? Yes, it does. And again, you can always check 5 to the -2 power. I get a crazy decimal and I convert it to a fraction. We get 1 over 25. Okay. Last one. How do you drop a log? Give it a swirly. I should hear more choral response for this. Swirly. Okay, thank you. How do you drop a log? Swirl. Better. We're about 30%. Okay. We start with the base. We circle around and pick up our power. B to the power of P. Make sure when you pick up your power This is called a superscript. Super, it's up high. And it's small, okay? Don't write b to the p because it looks like b times p to me. That would be wrong. Make that superscript really tiny. Equals the end, the argument. And that is exponential form. The same is true for these like log base 5. This is called a subscript. Sub, below. And it's a little teeny tiny script. So make it smaller. So watch your handwriting, please. Okay, how do you drop a log? Give it a swirl. Oh, that was so good. That was like 72%. All right, example 2. Rewrite the equation in logarithmic form. Again, you need example 2 and the directions. Rewrite the equation in logarithmic form. Okay, so we want to write this in logarithmic form. What form are we starting in? Yeah, this is exponential form. And I know that because it has an exponent, okay? And there's no log, really. I guess that's the real reason. There's no log in it. Logarithmic form has a log, always, always. So I know it needs a log. And what I want to know is what's the base. The nice thing is the base always matches. Here, our base is 2, base to a power of 5. We have log base 2. Those always match. And then you have to figure out what's the argument and what's the power. So log base 2 of 32 equals 5. How do you know if you did it right? How do you know if you did it right? How do you drop a log? Give it a swirly. So you just swirl it. Give it a quick little swirly and check. 2 to the 5th equals 32. 2 to the 5th equals 32. Yes, it works. Okay, I should see circles, these little swirlies all over the place on your paper. All right, 10 to the 1st equals 10. This is exponential form. I need a log. What's the base on my log? Log base 10. It always matches. Log base 10 of what equals what? Log base 10 of 10 equals 1. How do you know if you did it right? Give it a swirly. Sure. 10 to the 1st equals 10. Does 10 to the 1st equal 10? Yes. And in fact, log base 7 of 7 equals 1. And log base 22 of 22 equals 1. And log base, 31 of 31 equals 1. Are we getting the pattern yet? Okay, log base b of b equals 1. Always. This is a rule, ladies and gentlemen. Log base b of b always equals 1. We're going to use this rule on Thursday when we graph. Why? Why is this true, ladies and gentlemen? I'm going to ask why a lot. Why is this true? How do you drop a log? Swirly. Why is this true? Because if you give it a swirly, it makes perfect sense. B to the 1st power equals B. Does that make sense? Okay. So we're asking why a lot today, and we're always just going to go back to the swirly. Okay? All right. Excuse me. Here, log, what's the base? 1/2. Log base 1/2 of what? 8 equals Negative 3. How do you know if you did it right? Swirly. Give it a little swirly. 1/2 to the negative 3 power equals 8. Yes, that's what we started with. Here, last one, kind of a nonsense equation. Log, what's the base? 7 of what? Z equals Y. How do you know if you did it right? Swirly. 7 to the Y equals Z. 7 to the Y equals Z. Okay? How do you drop a log? Swirly. Okay. This is easy, right? Yes. Okay, last one. Example 3. Evaluate each expression. Evaluate each expression. Evaluate each expression. So first of all, what does evaluate mean? So I heard solve, and that's a common answer. And you guys might think that that's accurate. Solve is actually an inappropriate word. Evaluate actually means give me a value. So really, we want a value answer, meaning give me a number answer. And I know that's what you meant by solve. Work it out. Give me an answer, okay? So there's no X to solve for. That's why I don't like the word solve. But work it out. Give me an answer. Give me a number answer. Log base 3 of 81. We want to know, what does this equal? Well, we don't think in logs. You just learned how to do a log. How do you drop a log? Give it a swirly. So we do think in terms of powers. That's why I've been giving you these power grids all the time. So give it a swirly. 3 to what power gives us 81? 3 to what power gives us 81? Oh, 4. 3 to the 4th gives us 81. It equals 4. Okay. Log base 1/2 of 16 equals what? How do we do that? How do you drop a log? Swirly. So we do that. Let's think in terms of the swirly. 1/2 to what power equals 16? So this is often called the what power function. What power? 1/2 to what power gives us 16? Negative 4? Negative 4 is correct. How do you know if you did it right? You use your calculator. Whoops, clear. 1/2 to the negative 4 power equals 16. Look at that. You can always use your calculator to double check your little exponential equation. Here, again, we want to know, what does this equal? And again, we don't think in terms of logs. How do you drop a log? Give it a swirly. So 5 to what power gives us 1 over 125? Negative 3. Negative 3. Very good. Negative 3. We know that 5 cubed gives us 125. To turn that into a fraction, we want a negative exponent. Negative exponents create fractions. Or get rid of an existing fraction. That negative on this one flips the 1/2 and becomes 2. 2 to the 4th is 16. All right, now D is hard. D is a little different. Log base 27 of 3. This one is a little different because we're starting with a large base. Normally, we go from like a 3 and the argument is 81. The base is small. Our argument is a large value. Here, we have a large base and we're getting a very small number. So, this is weird. So again, I want to know, what does this equal? 27 to what power equals 3? Any thoughts? I didn't remind you of these. It is a fraction. That's very good. To go from a big base to a small number, negatives wouldn't work. Negatives create like 1 over 125. They don't necessarily make the value that 125 is still a large thing. But a fractional exponent is a good one. Remember, the square root of x can also be rewritten as x to what power? To the 1/2. If I have the square root of 25, I could write that as 25 to the 1/2 power. What is the square root of 25? 5. See how we started with a large, we got to a small value? Okay. The cube root of x would be x to the 1/3 power. What do you think the power needs to be here? Over 9? Let's see. I'm going to go the other way. I'm not so good with this, but I can use 3 and 27 another way. 3 to what power gives me 27? 3 to the 3rd gives me 27. Reciprocal that. The reciprocal power would be 1/3. 27 to the 1/3 power gives me 3. The cube root of 27 is 3. Okay, so if you know your powers, it's pretty easy to reverse and use that reciprocal power. Okay. All right, so this is 1/3. And it's going to take some time. You can do that on your calculator as well. 27 to the 1/3 power is 3. So you can absolutely check that on your calculator. All right, the last one is a rule that I don't ever really teach. The rule is, you'll notice we have a base of 10 and a logarithm inside the little exponent position. Logs and exponents cancel each other out. I'm just going to give you a rule. B to the log base b of x. B to the log base b of x. When we have a base and a log of the same base, they cancel each other out. They undo one another. And it just equals x. That is a rule. I never teach it because I don't use that method for solving. So looking at something like this, 10 to the log base 10 of 32, what do you think that equals? Just 32. The 10 to the log base 10 just sort of cancels out, okay? So those just cancel out. It's not easy. It's a cancellation property, but I don't teach logs that way. So, all right. Do you have questions for me? You guys have class practice 38. It looks long, but it should be